video, we'll look at the real-life application of the modulus function, and then we'll look at how the modulus function changes the shape of the graphs. Okay, so for the first example, Barry's walkie-talkie has a range of 2 miles. Barry is traveling on a straight highway, and it is at mile marker 2207. Write and solve an absolute value equation to find the minimum and maximum mile markers for which Barry's walkie-talkie will reach. Okay, so we know that Barry's walkie-talkie will work up to 2, because he's traveling on a straight line. We are saying that he's here, and it can go up to +2 or -2 miles from where he's standing. Okay, so the fact that it's going in both directions on a straight line, that means that really wherever Barry is, he will have up to ±2 miles range from where he's standing. Now, because the starting position x measures from 0 here, we are going to translate it by 207 miles. So we put x minus 207 here. So the fact that we have a plus and equal sign here means that we have x minus 207 with the absolute sign equal to 2. Okay, to remove these plus and minuses here, you put the absolute value sign or the modulus function on x minus 207. So that's the result that you get. Okay, so let's look at the next example with graphs. So in this question, we've been asked to sketch some graphs. We've been given a particular function where it's a quadratic function, and the modulus sign is outside of the bracket. So that means, first of all, we can factorize the quadratic, and we will have these two factors. Now, if we plot the original function, first of all, we'll have something like so. The graph will have a y-intercept of -10. If you don't know why, you simply take the value of x to be 0, because that's the value of x on the y-axis, and you substitute that into the function. So f of 0 will be -1, -5 times -2. So that's how we get -10. So, because the absolute value sign or the modulus function is outside of the function, the y values, okay, so the y values will always be positive. That means that it will never go below the x-axis. So this part of the graph that I'm crossing out will have to disappear, and it will reappear on the top side. Okay, so this part will appear above, and we no longer see this down here. So the final answer will look like something like so. The -10 will become a +10, and you do have to indicate that to get full marks in the exam when you sketch such graphs, because a sketch means you have to communicate the intersection points. So let's look at the next part and the next graph. We will be given the same function again with the same factors, -5, x minus 5 and x plus 2, and this time we have to sketch the graph where the modulus sign is inside the bracket. That means the x values will never go to negative. So if we have a look at the same graph and the same sketch again, this time we see that these x values where I'm shading, the graph will have to disappear. Okay, so what we'll be getting on the left side of the graph is a reflection of what it is on the right side. So this right side of the y, all the values on on the right side of the y-axis will reflect to the left, because that's what the function is asking us to do. Take the positive version of the x values. So finally, we will see something like this graph. The positive root of 5 will turn into negative root 5. Okay, so let's look at the next example. In this example, we simply have a sine curve with the domain of negative 360 to positive 360. First of all, if we take the absolute sign of the function, that means the y values will never be negative. So for the first part, for part A, we simply plotting what sine is between 360 and positive 360 and negative 360. So then for part B, the y values that are negative will have to turn into positive. So this part of the graph where it's below the x-axis have to be wiped off, and its reflection above the x-axis will have to be drawn. So this part will simply reflect up, and then you have to rub it off. And make sure when you do answer these questions, you use a pencil rather than pen, because you don't want to have crossings like I am putting on your graph. So in the part C of the question, we asked to calculate, sketch the graph of sine where x values are modulus. That means take the positive side of the uh, x values and reflect these on the left side. So when we reflect that on the y-axis, we will get this shape. Okay, so we have one more example here. We've been given a number of coordinates on this graph, and we've been asked to calculate, or rather sketch, the side of the function h. So we have to be careful and consider what y values will change. The part of the graph where it's already above the x-axis will remain unchanged. However, this part and this part here, where it's below the x-axis, will have to be reflected up, and we have to somehow get rid of this section. So the point 6 and minus 5 will go, point E will go to positive 6, where the x value doesn't change, but the minus 5 will become a positive 5. And you'll see that it should have a shape that will approach this value and have an asymptote which is remaining above the x-axis. And finally, you reflect that up like so. So in the end, you end up with a graph that looks like something on the bottom of the page, and you will have wiped off the bottom. Okay, let's look at part B, where x values are modulus. So you will simply take the positive part of the graph where x values are positive and reflect it to the left of the graph. That means all these values that I'm shading off need to be rubbed off, and we will make it space for the positive. So the point D will go to negative 3 because its x value is positive 3. Point C remains as it is, and point E will go to negative 6 comma minus 5. So you'll draw the graph like so. Hope you found that helpful, and I'll see you in the next video.